All right, it is time to talk about connective tissue. Here are the objectives. Pause and peruse if you want. This should look familiar, right? Levels of organization. We are focusing on the tissue level and specifically connective tissue. Remember, these are the things that we talked about in the introduction. So connective tissue includes connective tissue proper, fluid connective tissue, supporting connective tissue. It has cells and a matrix. Remember that matrix is a mix of protein fibers and ground substance. It is the most widespread and diverse tissue type in the body, and it has a wide variety of functions, including support, protection, transportation of materials, storage of energy reserves, and defense of the body. So let's move on to the specifics of connective tissue. First, connective tissue proper. All right, let's go over some of the cells in connective tissue proper. So we have fibroblasts, so they produce fibers, not a stretch, and ground substance. They're the most abundant cell type. Then we have macrophages. They engulf damaged cells and pathogens. They release immune system chemicals to call in reinforcements. We have adipocytes, they're fat cells. Mast cells, they're little mobile cells, and they have vesicles packed with chemicals. One of those primary chemicals is histamine, and that begins the body's defense. It begins that inflammatory response. Okay, let's go over the fibers found in connective tissue proper. So we have collagen fibers. They're long, they're straight, they're unbranched, but they're strong and flexible. The most common type of fiber in connective tissue proper. Then we have elastic fibers. They're made of elastin. Again, that should make sense. They're branched and wavy, and they return to their original length after stretching, so they provide some flexibility. And then there's reticulum fibers. So they're thin, they have this branching interwoven network, and they're the least common type of fiber. So which type of connective tissue fiber is most durable? That's the collagen fiber, right? Thick, not branched. Which type of cells are fat cells? Adipocytes. Now the types of connective tissue proper, and they're characterized based on the proportions of the cells, fibers, and ground substance. So we have loose connective tissue, also called areolar tissue, but we'll just primarily refer to it as loose connective tissue. All the cells and fibers that are in connective tissue proper, it has them, but just the proportions are different. It has an extensive blood supply. It provides cushioning and support. It stores lipids or fats. It anchors blood vessels and nerves. And it separates skin from muscle. Additionally, it fills the spaces between organs. Adipose tissue, which is a type of loose connective tissue, is fat. It's dominated by adipocytes, so that's the most common cell you're going to see. It provides padding and shock absorption and insulation and energy storage. Okay, so remember we're in the connective tissue proper category, and we have loose connective tissue. Now we have dense connective tissue. Dense connective tissue is mostly collagen fibers, very little of the others. It's tough, it's strong, it's durable because of the collagen. It resists tension and distortion, and it interconnects bones and muscles. It encloses joint cavities. So there's dense, regular connective tissue. So that means the collagen fibers are parallel, they're packed tightly, and they line up with the forces applied to the tissue so that they can resist those forces. We have tendons. that attach muscle, skeletal muscle, to bone. And we have ligaments that connect bones. Now, the ligaments often contain some elastic fibers as well, so they can tolerate more stretching. And then we have dense, irregular connective tissue. So it's kind of this interwoven network of collagen fibers, and it provides support to areas that are subjected to stress from many directions. So tendons and ligaments are great at providing that resistance in one direction, but dense irregular provides that resistance if there are many directions. So it's what helps to give skin its strength. Ligaments are what type of connective tissue proper? Dense, regular connective tissue. Adipose tissue is what type of connective tissue? Loose connective tissue. Now we're going to go on to fluid connective tissues. So for fluid connective tissue, there are cells in a fluid matrix. So they've got proteins dissolved in the fluid matrix, and they don't normally form large insoluble fibers because they need to be fluid. They need to be moving. Okay, we'll start with blood, one of the fluid connective tissues. It has four main components: red blood cells or erythrocytes. That's about half of the volume of blood, and it transports oxygen as a major function. White blood cells or leukocytes, those are immune cells, and they help protect the body. Then we have platelets or thrombocytes, and they're fragments of cells, not whole cells, and they're important for clotting. And then we have plasma, that's the watery matrix. So we have plasma, and then inside the plasma, we have three main types of cells, and in the plasma is going to be dissolved waste, dissolved nutrients, dissolved gases, anything that needs to be transported. Lymph is also a fluid connective tissue. Lymph is interstitial fluid. It means it's the fluid found between tissues. It surrounds the body cells. It's outside of blood vessels. It flows through lymphatic vessels and then returns to the cardiovascular system. So the heart is still responsible for its movement. It just flows outside of the actual cardiovascular system. It's monitored for signs of injury and infection. And we have lymph nodes, for example, here, that your doctor might check if you are not feeling well to see if you have signs of infection, which could be swollen lymph nodes. What cells in blood help with clotting? Platelets, right? But they're not cells, they're cell fragments. Okay, fourth, we have supporting connective tissues. So they provide a strong framework that supports the body. They have numerous fibers and sometimes calcium salts in the matrix. Okay, cartilage, the first type of supporting connective tissue we're going to talk about. The only cells found in cartilage are chondrocytes, and they're the cells that produce the cartilage. Cartilage is avascular, so it limits the repair because there isn't an efficient blood supply. And cartilage bends easily, but it is difficult to break. So hyaline cartilage, it's supporting connective tissue again. It's the most common type of cartilage. It has closely packed collagen fibers. It's tough but flexible. I always think that the cartilage pictures look like little spaceships floating around. That's how I remember it. Where do we find hyaline cartilage? Well, it connects our ribs to our sternum and our respiratory passages, and it covers the ends of our bones. Then we have elastic cartilage. So again, that spaceship-y look. It has numerous elastic fibers. That should make sense. It's very resilient and flexible. And it's found in the pinna, your outer ear, and also the epiglottis, that flap that covers your trachea when you swallow. And then we have fibrous cartilage, which surprisingly is called fibrocartilage. It has little ground substance, so it's fibrous, it's more tough. It's primarily some interwoven collagen fibers, fibrous. It's durable and tough. So we find it in the vertebral discs, so those discs that exist between our vertebrae, our pubic symphysis, where the pubic part of our hip bones join, and also around some joints and tendons for additional protection. Okay, bone, the second type of supporting connective tissue. Bone is also called osseous tissue. It has osteocytes, which are the mature bone cells, and we'll talk about this in greater detail in the skeletal system. Bones resist distortion until they actually break. They're strong and resilient due to the matrix. So what is the matrix made up of? Well, mostly calcium compounds and some collagen fibers. So bones have some flexibility, but there's very little ground substance. But bone is also vascularized, which means it has a blood supply. So if you break a bone, there's bleeding. And bone is constantly being remodeled and repaired throughout our lifetime. Every 7 to 10 years, it's estimated that our entire skeleton would have been replaced. What type of cartilage covers the ends of bones? So think about it, because this is common. So it's hyaline cartilage, the most common. The pinna is composed of what type of cartilage? That one is elastic. And there you have it, all about connective tissue. We went through all the types, fluid, supporting, connective tissue proper. Hopefully in the process, you learned something new today.